9.6a, counting principles. We're going to do lots of reading and understanding what that reading is doing. All right, so welcome to the beginning of statistics. Evan's going to read for us. He's going to start us out.
8 pieces of paper are numbered from 1 to 8 and placed in a box. One piece of paper is drawn from the box, its number is written down, and the piece of paper is replaced in the box. Then a second piece of paper is drawn from the box, and its number is written down. Finally, two numbers are added together. How many different ways can a sum of 8 be obtained? Or of 12 be obtained?
All right, fantastic. So what's important? Okay, numbered 1 to 8. All right, that's important. What else is important?
It's being replaced.
It's being replaced. That's extremely important, and this was even italicized for us. All right, what else is important? A sum of 12. All right, a sum of 12. So, how can I get there? How can I have numbers 1 to 8 being replaced to have a sum of 12? How can I get there?
6 plus 6.
6 plus 6. Good. So we can have 6 plus 6. What else?
10 plus 1.
Okay, we can't have 10 plus 1. No, that doesn't add up to 12, first of all. And we don't have a 10. All right, so there's 2 reasons we can't have that. But good try. 8 and 4. All right, so we could do an 8 and a 4. What else? A 7 and a 5. What else?
That's it.
Because you have 5 and 3.
There we go. No, not 5 and 3, but 5 and a 7. What else? 4 and an 8. All right. So how many different ways can we get it? 5 ways. All right. 5 ways to get it. All right. Let's do the next one. Here we go. Joe Mars is going to read it.
8 pieces of paper are numbered from 1 to 8 and placed in a box. 2 pieces of paper are drawn from the box at the same time, and the numbers on the pieces of paper are written down and totaled. How many different ways can a sum of 12 be obtained?
All right. Fantastic. How can I get there? What's the only difference? It's at the same time. It's at the same time. All right. So how do we get there?
So would have 4 ways.
I will have 4 ways, but how will I get there? A 4 and an 8. How else? A 5 and a 7. How else? A 7 and a 5. How else? An 8 and a 4. So there are 4 ways. All right. Keep moving. Here we go. So you try this one. So determine the number of ways a computer can randomly generate one or more of such integers of 1 through 12. And now I have 2 distinct integers whose sum is 8. Well, what does distinct mean? Must be different numbers. All right. 1 and 7. How else? What? 2 and 6. How else? 3 and 5. How else? 5 and 3. How else? And? So how many ways? 6 ways. All right. All right, let's do some. So I need to read a counting principle. So Cade's going to read our counting principle.
Let E sub 1 and E sub 2 be 2 events. The first E event, E sub 1, can occur in M sub 1 different ways. After E sub 1 has occurred, E sub 2 can occur in M sub 2 different ways. The number of ways that 2 events can occur is M sub 1 times M sub 2.
All right, this is how I'd break down the fundamental counting principle. 2 separate events happen. They are separate events, but they go together. If they go together, you multiply. All right? So events are happening. They have different ways of happening. Okay? But if they go together, you multiply. That is the fundamental counting principle. All right, so here we go. How many different pairs of letters from the English alphabet are possible? Well, what's important here? Pairs. Pairs is the important part, and the English alphabet. All right. So what does a pair mean? There's going to be 2. So this is how I'd kind of help you do it. I'd put in 2 blanks. All right. I'd put in 2 blanks. So how many choices do I have to find an English alphabet letter for that first one? 26. All right. I have
26.
good. All right. And then how many letters would I have for that second one? I'd have 26. Now, does it say that they have to be distinct? No, they don't say that they have to be distinct. So I have 26 times 26 ways of doing it, which ends up being 676 ways. All right, does anybody want to list them out? No?
No.
No? Nobody wants to do that? All right. We could do AA, AB, AC. No, you don't want to list them? All right. I don't think we want to either. I want to make one up now. I want to know how many ways can we have two distinct vowels followed by a consonant? Consonant. All right. So, how many letters are we going to be choosing? We're going to be choosing 2 letters. Or not 2 letters, just kidding. How many letters are we going to be choosing? We're going to be choosing 3. All right. So the first 2 are going to be vowels. All right. So the first 2 are going to be vowels, and then the third one is going to be a consonant. All right. So, how many vowels do we have? What are my vowels? A, E, I, O, and U. All right, so I'm going to say that there's how many? There's going to be 5. There's going to be 5 vowels. So, how many consonants are we going to have? 21. All right, good. So, how many vowels can that first one be chosen from? 5. I'm going to have 5. All right. Well, how many vowels would I choose for this second one? How many ways can I choose that second one? 4. Why is it 4 and not 5? Because it's distinct. I already used one. All right. And then how many consonants do we have to choose from on that next one? 21. So now I have 5 times 4 times 21, which ends up being how many different ways? 420 ways. All right. Pretty good? All right, let's see somebody talks on the telephone a lot. McKinley, go for it.
Telephone numbers in the United States currently have 10 digits. The first 3 are the area code and the next 7 are the local telephone number. How many different telephone numbers are possible with each area code?
You need that.
Note that at this time, the local telephone number cannot begin with 0 or 1.
All right, what's important from this?
10 digits.
Not really. What?
Cannot begin with 0 or 1.
Okay, can't begin with 0 and 1. Agreed. What else is important? Okay, true. You're missing something big. I don't count for area code because it says what? Within each area code. So I don't actually need to worry about the area code. All right? Because it says within each area code. Now, how many numbers would I have to choose from for this first digit of my telephone number? I have 8 to choose from. Why is it only 8? Because I can't be 0 or 1. How about my second one? 10. How about my next one? 10. How about my next one? How about my next one? And my next one. And my next one. All right, so I have an 8 followed by how many zeros? 6 zeros. So how many different ways is it? 8 million different ways to find a telephone number within that area code. All right. Do we want to list them all out? Okay. All right, good. All right. Here we go. So now we're going to talk about a permutation. I need a reader. Thank you so much, Ryan, for volunteering.
Permutation of n different elements is an ordering of the elements such that one element is first, one is second, one is third, and so on.
All right. So this is what I want you to write down. Permutation, order matters. All right. Permutation, order matters. Okay. All right, so here we go. This one, how many permutations are possible for letters A, B, C, D, E, and F to be written? All right, so this kind of goes along with counting principle a little bit. How many letters can I choose for that first one? How many letters can I choose for that first spot? 6. How many letters can I choose for that second one? 5. How about the next one? 4. How about the next one? 3. How about the next one? 2. How about the next one? 1. This is really the same thing as 6 factorial. And what do we know 6 factorial is? 720. All right. So there's 720 different ways to just put in A, B, C, D, E, and F. All right. Now this is what I think is so cool. How many people can come in first? 6 people can come in first. How many people can come in last? Only 1. Interesting. All right. So here's what a permutation is really doing. So we did combinations in CR, right? Now we're going to talk about permutations in permutation R. And when do we use a permutation? When order matters. All right. So if you're going to build it old school, it's just like this. But anyway, you can just use your calculator. That's what we'll probably be doing. All right. So horse racing. Courtney likes to ride horses. Go for it.
8 horses are running in a race. In how many different ways can these horses come in first, second, and third? Assume that there are no ties.
No ties in horse racing. All right. How many horses can come in first? 8. How many horses can come in second?
7.
Only 7. How many horses can come in third? 6 horses can come in third. So it's really just a counting principle of 8 times 7 times 6, and we end up with what? 300 what? 36 different ways. Now, this is also another way we can do it. Does order matter of horse racing? Does it matter if you come in first, second, or third? Yes, definitely. All right. So it is a permutation. I'm choosing from 8 horses, and I'm choosing how many? 3 horses. So guess what 8 permutation 3 is? 336. All right. So that is another way to tamper. However, it really does work with a counting principle as well. All right. Go for the gold worksheet. 9.6a.